maybe let's discuss some of these questions. So the first part, we are talking about the simplification, reduction, right, into the big O. So Yiqie, so what is the answer for the first one?
O n to the power of 3.
O n to the power of 3. So why is it O n to the power of 3?
Because I think it's based on the biggest entry, based on the complexity of that.
Right, so these are different terms. Now how do we know these are different terms? If they are separated by addition or subtraction, they are different terms. Now within these terms, among these terms, we then try to find which one is the largest one. So this is n squared, this is n cubed, so n cubed is the largest one. So then we keep the n cubed, and how about the 3 there?
Ignore it based on the
Right, yeah, so if it's a constant, we drop it. Alright, second one. So Jaslyn, what is the second one here?
N squared.
N squared.
Yeah.
Okay, why is it n squared?
Because it's the biggest.
Alright, so n squared log n and n, right? So the largest one is n squared. Okay, and there's no constant involved here. Alright, the third one. Okay, Anmol, what is the third one here?
N log n.
O n log n. So why is it not just O n? I mean, n and log n is larger, right?
N log n is larger than n linear.
Alright, okay. So this n log n, they are not two terms, they are one term, right? So we cannot separate them because they are not separated by addition or subtraction. So what we are comparing is this term and this term. And n log n is larger than just n. Alright, any clarification here before we talk about the next one? Alright, so the next one, we are concerned with the complexity of some of the problems that we have seen earlier, right? So this is the same problem as what we are trying to count, which was the comparisons. Now earlier, we have done this part, and we say that the number of comparison operations is 9. So which means that this algorithm, what is complexity? N? So regardless of n, it's always 9. This is what we discussed earlier, right? Regardless of what n is, it's always 9. So what does it mean? It means that it's actually a constant. If it's a constant, what is it then? O1, right? Now, we don't write O9, right? Or O12, or O whatever constant. To indicate something is a constant, we just say O1. So O1 means that your input size does not affect the number of operations that you're going to do. Now the next problem, we are asked to look at the smallest difference between any two numbers. And earlier we have analyzed the algorithm and we come up to an expression in terms of n, right? So this is a number. Now after we get this number, then we need to simplify it. So what is the big O of this one? So how do we get n squared? So first we try to figure out what is going to be the overall expression, right? So n minus 1, n over 2 is the same as n squared divided by 2 minus n over 2. Now how many terms are there? So there are two terms, right? So they are separated by the subtraction. So which one is more dominant? The n squared. So why is it that we don't write O n squared divided by 2? Because the half here is a constant. So then, in this case, we're going to write this as O n squared. Alright, so we look at an algorithm, we figure out the worst case, we count how many operations, and finally, we simplify to the big O. Now, the final part, we are then talking about finding 3 students with different last names. And we said that there are n students in the class, we want to find 3 students with different last names. Now, what is your algorithm to try to solve this problem? Does anyone want to volunteer an algorithm? Because we can only analyze it once we have an algorithm. If we don't have one, we can analyze what is going to be the complexity. Yes, Amanda?
What I did was similar to the previous question before this. So what I did was, you have an I, right? So your I's range from the first person in class to the last person in class. Then I compare I to J, which takes the range of I plus 1 to the last person in class.
Mm-hmm.
And then the second last person in class.
Okay.
And then I compare I again to maybe K, which takes the range of I plus 2 to the last person in class.
Alright.
So then my if statement will be like I equals to J and I equals to K. Yeah.
Mm-hmm.
And then if I return true, means that they are all different. If it's false, then the algorithm will continue on.
So I not equal to J. I not equal to K.
Oh yeah, sorry,
Is
not
that right?
equal, yes.
Okay, alright.
Yeah.
Alright, so that means in some sense what you're doing is that, okay, you keep a short list and you want to put people's name on the list, right?
Yeah.
So the first name is going to go into the list, and to get into this list for the second name, it has to be different from the first one. And for the third one, it has to be different from the first two, right? Now, in that case, given that you go through the list from 0 to n minus 1, what would be your worst case?
N square.
So what would be the worst case? That means like which are the answers here?
Like everything, only at the last point, then you find the answer.
Only at the last point,
Yeah.
then you, okay, alright. So now let's say, to make it into this list, for the first person, he can just go into the list, right?
Yeah.
Because nobody else has the same name as this guy. Now, somewhere along the line, we know that the second person is going to go in. And finally, the third person is going to go in, right? Now, for this person to go in, who do we have to compare to? So for the first one to go in, you don't compare to anyone. So it just needs to go in, right? So that means that for this guy, it needs 0 comparison. Now, for the second guy to go in, how many comparison does it need? 1. Okay, so that means that before you find this guy, every one of them, you need 1 comparison. Because there is already 1 in the list, right? Now, after you find the second guy, it goes in, right? Then for the next one, how many names do you have to compare to? You have to compare to 2, because now there are 2 names on the list. So the rest of them are going to take 2, right? So now, knowing that, what is the worst case? The worst case will be the most number of comparisons needed. Which in this case, it means that you're going to pick the first guy, and then you're going to pick the second guy, and then you're going to pick the last guy. Because for the first guy, he needs 0 comparison. For the second guy, he needs 1 comparison. How about this guy? So there are n minus 2 numbers left, right? And each one has to compare to 2 names that are already on the list. So then the total number of comparisons will be 0 plus 1 plus 2n minus 2, which is 2n minus 2 plus 1, which is 2n minus 1. So what is a big O? O(n). So we just need to figure out what is the worst case. Now, could any other thing be the worst case? So for example, if you don't pick the first 2 guys, it means that you're going to have some of them that only has 1 comparison. And that's actually not the worst case yet. Alright, so coming back to the point, you are given a problem. First, you need to figure out what is the worst case. Well, first you need to figure out an algorithm to solve a problem, right? Then figure out the worst case. Then count the number of operations in the worst case. Then you simplify to the big O. Then once you do that, you should be able to get what is going to be the complexity of an algorithm.